take that forward and say, well, how is exercise going to affect that process?
Okay, so what exercise can help that process in a number of ways. What exercise does, as a sort of generality, is exercise forces your muscle tissue. You're voluntarily creating a significant number of muscle contractions and elongations inside of your skeletal muscle tissue. So when you go exercise, whether you're doing push-ups or whether you're doing pull-ups or whether you're running, biking, hiking, swimming, playing basketball, you name it, any of those motions, you're forcing your skeletal muscle to contract and elongate hundreds, if not thousands of times. So it's performing mechanical work. And as a result of performing mechanical work, your muscle tissue requires glucose and fatty acids for energy. Those are the two principal fuel sources during exercise. So your muscle tissue is going to basically say, where can I find glucose? And the answer is, it can find glucose in many places. Number one, it can find glucose as glycogen, which is the stored form of glucose inside of the muscle tissue itself. So great, it's going to go degrade glycogen. It's going to pull off those extra glucose units. It's going to then oxidize those units and get ATP for it, which is a good thing. Then it's going to say, well, where can I get fatty acids? And fatty acids exist inside of the muscle tissue because, like we have been talking about, they've overaccumulated over the course of time. So exercise is a way to actually get to that lipid droplet and start to pull off those excess fatty acids and send them to the mitochondria and turn them into ATP. And that's a good thing because ultimately what we're looking for is ATP. So your muscle tissue can burn or oxidize, I should say, fatty acids, and it can oxidize glucose, and that's a good thing. And what happens is that during exercise, you actually end up with a significantly elevated rate of fuel usage. So that means you deplete your glycogen stores, you can deplete your fatty acid stores, and that's a good thing because then your muscle tissue becomes very hungry after you're done exercising. And when I say hungry, I don't mean that your muscle tissue is basically, telling you that you should eat food, but in reality, there are signals that then tell your brain, oh, wait a minute, now it's time to put nutrients back inside of your muscle tissue. So what ends up happening is that the next time you eat food, you can eat food and the glucose and fatty acids that came from that food can actually get put into your muscle tissue using less insulin. And that's the key. Insulin isn't as necessary to put glucose back into your muscle tissue. It isn't as necessary to put fatty acids back in your muscle tissue because in the 3 hours following exercise, there is an increased ability for both fatty acid and glucose uptake inside of your muscle. And that is a non-insulin dependent process, meaning that insulin isn't required as much. So your insulin requirements post-exercise go down significantly by as much as 50 to 60%. And that's a good thing because that means you can take in food for reduced insulin requirements. And then over the course of the next 24 hours in between your exercise sessions, you actually are you're still able to utilize and store more glucose and fatty acids inside of your muscle tissue than under normal circumstances. And at all points, you're using just a little bit less insulin than you normally would. So what that means is that you have now reduced your insulin requirements both during exercise, immediately following exercise, and as a generality. And that's a good thing because it makes your pancreas work just a little bit less hard. And that's a good thing because the less insulin you're forcing your pancreas to make, the less the less work you're going to force your pancreas to do over the course of time. And that's going to preserve beta cell function over time.